an important circuit to know about for all types of electronics is one that's known as the OpAmp. And the word op refers to a mathematical operation, and amp means that it's an amplifier device, which is in this particular form, looks like this. It has been universally ascribed to use the triangle instead of a square. And you'll notice that there's a minus and a plus here, but it doesn't refer to voltage polarity particularly. What it refers to is that a signal going into this one is going into the inverting terminal, and is coming out here at the output inverted. For example, if I have a voltage going in a positive direction, the output will be going in a negative direction. Now in the case of this terminal down here, this is called the non-inverting terminal. So if I have a signal that's going in a positive direction, the output will also go in a positive direction. These op-amps have a lot of different other type configurations between inverting and non-inverting amplifiers. They can be used as difference amplifiers. They could be used for different types of feedback for oscillation, or it could be something that has to do with comparing two voltages. So there's a lot of different types of circuits that these particular devices are good for. Sometimes you can find op-amps in maybe 2 or 3 or even 4 inside of a single IC, but oftentimes we have what's known as a very common one, the LM741. It's a bipolar junction version of the op-amp, and we also have various types that are JFET input. Some of the things that really helps in these is that they don't have so many manufacturing flaws in the JFET between the input signal and the output. They're very much isolated because of the high input impedance of the JFET amplifier, as opposed to the lower input on the LM741. Even though it has an input resistance of 2 megohm, sometimes it's desirable to have a much higher resistance. And that's where JFET and MOSFET type op-amps are important in those kinds of signals.